Okay, in chemical properties, you need to know the chemical properties of group 1, first of all. So first we'll talk about group 1. Group 1 में we have lithium, sodium, potassium, rubidium, cesium, francium. Few trends in the group 1 and the certain typical properties of group 1. So those who have done IGCSE and I think ICSE also had the group 1. So this will be a repetition for you. Group 1 metals are known as very reactive metals. Okay, group 1s are known for their high reactivity. Lithium is very reactive. Lithium is very reactive, but in the group it's the least reactive. In the group it's the least reactive, but by itself it's very reactive, which means that as you go down the reactivity increases tremendously. So by the time you come to francium, it's very reactive. So group of most reactive metals, so much reactive that they need to be stored under oil. They need to be stored under oil. So if a group 1 metal you keep it exposed open, it will react with the oxygen and the moisture in the air. It will quickly react. So you cannot keep the group 1 metals like that. So they have to be kept under oil. They are soft. Usually metals are very hard. Like if you have an iron bar, you cannot cut it with knife. You cannot use a kitchen knife and cut the bar. Of course, no. But these group 1 metals are so soft that you can cut them with a knife, like how you cut butter. So you can cut it like that. They have low densities, so much that lithium, sodium, potassium, particularly these three, will float on the water. So this is very unusual property for a metal. No, we know that if I put a metal, it will sink in the water. But these metals, and typically the lithium, sodium, potassium, will float on the water. Low melting point, boiling point, and they all form singly charged cations, matlab X plus. So Na plus, K plus, Li plus, etc. And reactivity increase down the group. So these are the things that you should know about group 1. In the trends, reactivity increases down the group. So from lithium to francium, francium is most reactive. Density increases. So as I said, that lithium, sodium, potassium will float on water, but they will sink in the water, which means density, it's getting more denser. Melting point and boiling point decreases. So they already have low melting point, but lithium will have the least melting point, highest melting point. So lithium will have the highest melting point. Okay. But I have seen that so far, questions on this part has hardly been asked. But you should always keep this data ready because it's there in the syllabus. But I don't recall any, question asked on this. So reaction with water. Reaction with water, they will typically ask for these three metals: lithium, sodium, and potassium. So what happens when lithium, sodium, potassium reacts with water? So first of all, when I put this metal on the water, they will not sink. The piece of the metal will float on the water. So first, first observation is that when you put these metals on the water, it will float. The metal will float. All three will float because we know all three are less denser than water. One more observation is that they will not just float. They will they will not be stationary, they will move around on the water. Okay, so they will move around on the water.
You lagged out.
Yeah, I'm waiting,
Oh, like
yeah, I'm waiting. Yeah, okay. So one thing is that I said float, they will not only float but they will move around. Like they will not be stationary at one place, they will keep moving on the surface of the water. And potassium will move most quickly. Now that's how you compare, because lithium, sodium, potassium may, you'll always get the behavior of sodium more vigorous than lithium and potassium most vigorous. This is the order of the reactivity. Okay, they all will release bubbles. Any idea what these bubbles are of?
hydrogen.
Hydrogen gas given out. So when these metals react with water, they form alkali. मतलब lithium अगर है तो lithium hydroxide, potassium है तो potassium hydroxide, etc. and hydrogen gas. So bubbles, all three will give. Metal piece will decrease in size, of course, as it reacts, it will decrease in size. But one specific thing about sodium and potassium is that they form a ball. Like the piece of the metal that I am putting is of whatever shape. Suppose if I'm putting a cuboid shape, when it decreases, it becomes the round shape. Okay, because the edges, the sharp edges will get rounded off and it will become a ball because it's melting. Basically, the metal is melting due to the heat because it's an exothermic reaction. All these reactions are exothermic reaction. So it will melt the metal also. In fact, in potassium, the heat given out is so much that the gas hydrogen will catch fire. So heat produced will ignite the hydrogen and it will burn with a lilac flame. So anyone has any idea why the flame color is lilac?
So because of light as
Of which
potassium
metal?
gives out
Potassium.
pot-
Yeah. So potassium ion gives a lilac flame. That's correct. Who answered the question?
so me Krishna.
Achha. Krishna, you've done IGCSE? You said yes or no?
So I said yes.
Achha, okay. All right, so that's the reason why you get lilac flame, and the difference also will be in the vigorousness. So lithium less vigorous, sodium will more vigorous, and potassium will sodium will be more, potassium will be most vigorous. So there will be increase in the vigorousness of the reaction also. So everyone, I suggest spend time on this table and note down the differences, similarities and differences. Similarities may you can say bubbles, similarities, metal floats, similarities, metal moves around, similarity, heat produced, similarity. Okay, so in fact I have an answer also from the mark scheme on the same. Yep, this one. So similarities and differences in lithium and potassium reacting with water. So please spend time on this, note down these points.
Hi, so
Hello.
Voice on leader Bhagesh. Bhagesh also.
your
Oh,
question is
I
Suhani.
forgot to speak to him.
Yeah, Suhani, Mahir, and I were Bhagesh. So
No, you should have reminded me. Actually, I would have told him that to leave you early. He would have done that. Anyways, okay. So that's all you need to know about Group 1. Group 17, halogens. So halogens may fluorine, chlorine, bromine, iodine. These are the common properties of all of them. That all of these will react with non-metals to form covalent compound because they are non-metals. They will react with metals to form ionic compounds because it's a give and take. All are colored. So colors may fluorine is pale green, No, sorry, pale yellow. Chlorine is pale green. Bromine में they accept the reddish brown. Okay. Or orange. They accept reddish brown or orange. And iodine is, when it's solid, it's purple. Sorry, gray. Solid is gray. The vapors are purple.
And so what about aqueous?
Aqueous में, yeah, aqueous में bromine and iodine, these have different colors. See, aqueous में when you're talking about when bromine is produced as a product in an aqueous solution, when iodine is produced as a product in aqueous solution.
So,
Yeah,
are these notes in the info book?
this is info book only.
Okay.
So,
Hmm.
what exactly are we doing? Because I'm a bit confused. I just joined in.
We're just
I
doing
see.
group 17. Why are you confused? You don't know
No,
group 17, you don't know halogen.
No, sir, I just entered. No, like, what did I
And
miss?
didn't you ask me on the personal chat, what am I doing? Didn't I clearly reply that what am I doing now? What am I doing at 8:30? What is the
Yes,
confusion
no,
about?
what have I missed? Because I just entered. Not, I just finished Bhagesa's class.
Huh, so you asked the question that, sir, what have I missed? Don't say
Yeah,
I'm
that's what
confused.
sorry, yeah.
Huh. So what you have missed is group 1, which is same
Yeah.
as what we did in IGCSE.
Oh, okay.
Okay, so that you can read and you can
Yeah.
understand that. Okay, Mahir, you have done group 1s in 10th?
Yeah, yes, sir.
Yeah, okay. Okay, so bromine में and iodine में, when it is the aqueous product, then bromine, iodine का they usually say yellow brown or red brown. Okay, and bromine you can say orange or red brown. Of course, if you're writing both together, then don't write red brown for both. But there is a clash here. Mark schemes I have seen that use red brown for both on different occasions. But bromine, orange is fine, and this is yellow brown. So iodine is yellow brown when it is produced as a in the water. But solid iodine agar hai to gray, and the purple vapors which are coming out of the solid, because iodine sublimes, it undergoes sublimation. So those vapors are purple in color. Okay. All have the charge -1 and all are acidic hydrides. Okay, now the trend may reactivity decreases down the group. So fluorine is the most reactive. Chlorine is lesser, bromine is still lesser, iodine is the least reactive. Okay. The colors are given here. States. States may fluorine is a gas, chlorine is a gas, bromine is a liquid, and iodine is a solid at room temperature. Those are the states. And colors. Reactivity decreases down the group, which means this is the most reactive. And iodine will be the least reactive. Okay, now this reactivity, which is decreasing the down the group, you can have many MCQs based on this. So what you need to understand is that who can displace whom. So I think we'll make another table to understand that. So reaction between halogen and halide. reaction between halogen and halide. So first of all, I'll clarify. When I'm saying halogen, I'm saying fluorine, chlorine, bromine, iodine. When I'm saying halide, I'm talking about ion, the anion, fluoride, chloride, bromide, and iodide. Okay. More about them. Halogen are elements. Okay. Halides are compounds. Well, how are they compounds? Where is the cation? Cation is missing there, but I can put any cation like fluoride. I can take potassium fluoride, I can take sodium fluoride, lithium fluoride, calcium fluoride, whatever. So whatever be the cation, if it's fluoride, chloride, bromide, iodine, matlab it's in the compound form. So it's in the compound form. So this cannot exist on its own. Huh? This cannot exist on its own. Yeah, this can exist on its own because they are elements. They are diatomic molecules. So when I'm saying halogen reacting with halide, I'm talking about, let's say, fluorine reacting with chloride, fluorine reacting with bromide, fluorine reacting with iodide. Okay, chlorine reacting with fluoride, chlorine with bromide, chlorine with iodide. So every halogen with the other halogen ka ions. Okay, so and so on. So I have to see out of this crisscross reactions, which reactions will take place and which reactions will not take place. So fluorine, chlorine, bromine, and iodine reacting with fluoride, chloride, bromide, and iodide. Okay, so first of all, we will see which reactions are like not applicable. Okay, so fluorine fluoride not applicable. Chlorine chloride, matlab the of course the anion will not react with its own element. So these are the reactions which are not applicable. Now, out of the remaining reactions, tell me about this reaction. Fluorine with chloride. Will this take place or no?
No, right?
No, sir.
It will take place. It will take place because this is the most reactive. Remember, he can displace everyone.
Okay, okay, never mind.
Okay, fluorine will displace everyone. So what are the products here? You will get chlorine plus fluoride. Here you will get bromine plus fluoride, and you will get iodine plus fluoride. What about chlorine? Chlorine with fluoride?
No, it won't take.
Yeah.
That won't happen.
It won't happen. Chlorine with bromide?
Bromine.
It will
Protein
happen.
plus.
Bromine plus chloride?
And
Iodine
Iodine plus
chloride.
fluoride.
Bromine plus fluoride here?
No,
Won't
won't
happen.
No
No.
reaction.
Chloride
No.
also no.
No
Here
reaction.
iodine.
iodine
Iodine
plus
plus bromide.
Plus
bromide.
bromide.
And these three
Nothing.
will not take place. Okay. Okay, so that's about the like who will react with whom, who can displace whom. Okay. Next part. You should also know that which combination will react most vigorously or most exothermically. So usually they ask about group ones and combination of group one and halogen. So group one may we have lithium, sodium, potassium, rubidium, cesium. Okay, and here we have fluorine, chlorine, bromine, and iodine. So which combination do you think is the most vigorous out of this? Like which halogen reacting with which group one will be the most vigorous reaction combination?
Lithium and fluorine.
Sodium.
Cesium and chlorine.
Fluorine.
Because he is the most reactive in his group, he is the most reactive in his group. So this combination is the most reactive. Okay, so most exothermic will be formation of cesium fluoride. Is this part clear?
Yes, sir.
And least will be lithium iodide. That will be the least. So once they give you option MCQ may, so you should select the correct combination. All right, this is the last part of the chapter. After that, we are done with the SL part of periodicity. Now here in this part, usually in the chemical properties, questions come from this, usually. And often students will lose marks. That's because they will not learn these reactions, so they assume that I know, but it often happens that in the exam hall either you'll forget the formula or the name or the product, or what should I react with, should I react with water or acid, is it soluble or insoluble. So all those decisions you don't take, so you end up writing a wrong reaction or some mistake in the reaction and you end up losing the marks. So I will tell you where exactly you will lose marks so that you can take care and not lose those marks. So this part of the chapter talks about oxides of period 3. Oxides of period 3. So period 3 may oxides are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and there is chlorine and argon also, but we ignore that in this part. So we want to talk about these 6 elements jiska oxide. So sodium oxide, magnesium oxide, aluminium oxide, silicon oxide, phosphorus oxide, sulfur oxides. First of all, you should know the formula of all the oxides. So I guess you should know this, but the phosphorus ka particularly we will discuss. Sodium oxide, because Na1 plus O2 minus, so Na2O. Mg2 plus O2 minus, Al3 plus O2 minus, so this formula. Silica, we know that this is macromolecular, same like diamond structure, SiO2. Okay, now the formulas of oxides of phosphorus. Okay, now phosphorus forms 2 oxides, P4O6 and P4O10. Now one would wonder, why P4O6? Why can't I divide this formula by 2 and make it P2O3? Similarly, here also I can divide by 2 and make it P2O5. Like, why double that? P4O10Q. Why not P2O5, the simplest version, simplest thing? But remember that this is a molecule. Okay, it's a molecule. It's not an ionic compound. Ionic compound, you can take the ratio. You can say 2:3 ratio, 1:1 ratio, 2:1 ratio. Molecules, you can't take that. For example, glucose, if you know C6H12O6. So do we have to write the formula of glucose like this, or can I divide this by 6 and make the formula of glucose as CH2O? Is that allowed?
No.
No, sir.
No.
Because molecular formula should tell you the content of one molecule. So which are the atoms in one molecule? So one molecule of glucose does not have 1 carbon, 2 hydrogen, and 1 oxygen. This is empirical formula. Empirical formula is a different thing. One molecule of glucose will have 6 carbons, 12 hydrogen, 6 oxygen. So I need to write the entire thing. So same here also. Now the name, how do you name these? दोनों का name will be phosphorus oxide.
That's it.
No.
I was expecting some like grand name, but the way you said the name.
But I have to wait, no? I have to wait till I finish writing. Now you have to wait till I finish writing and continue speaking. Okay, now dono ka name is phosphorus oxide. But if I keep the same name for both, then there would be a confusion. If I'm saying phosphorus oxide, how does the student know I'm talking about this one or this one? So there has to be a difference between them. Yes, and the difference is the oxidation state of phosphorus in each one. Oxidation state of phosphorus in each one. In this one, oxidation of phosphorus is 3. So I will write Roman 3 in the name. That is this one. Okay. P4O6 ka name is phosphorus 3 oxide. And what should be the oxidation state of phosphorus in this? Any idea?
5.
Ajwani answered that?
Yeah.
Did you know that or you just found out?
I realized right now.
Oh, great. Proud. Impressed. Okay, so phosphorus 5 oxide is this. Because the oxidation of phosphorus is in this is +3 and इसमें +5 है. Okay, so remember the names are phosphorus 3 oxide, phosphorus 5 oxides, and formulas are not P2O3 and P2O5. It is P4O6 and P4O10. Sulfur ka oxides, you are aware of SO2, SO3 because I think all the students have done contact process in the 10th grade. So we know sulfur dioxide becomes sulfur trioxide in that. So this you are aware of. But again, we'll just see. So sulfur dioxide में sulfur का oxidation state is +4 and sulfur trioxide में it is +6. Okay, remember that +4 here and +6 here. Okay, so what about these oxides? They will not ask the formula, of course. So that's not the main discussion. Main discussion is they will ask you about the acid-base character of these oxides. So out of all these oxides, you should know which ones are acidic and which ones are basic. So sodium oxide, magnesium oxides are basic because metal oxides hai. Metal oxides is basic. So big deal, even aluminum oxide is metal oxide. But we know the amphotericness of the aluminum oxide. We have learned that in grade 10. So basic, and amphoteric. All others are acidic. All others are acidic. Okay. So you should first of all know who's basic, who's amphoteric, who's acidic. Not only that, but you should also know a reaction of each one of them, which proves that, yeah, this guy is basic, this guy is acidic, this guy is amphoteric. So you not only have to know who's like which is what, but also you should have a reaction ready in your mind to be written that proves that, yeah, this is an acid, this is a base, and this is an amphoteric. Okay, now how do you write those reactions? First of all, about basic. To prove that they are basic, make them react with water and they should form a metal hydroxide. They should form a metal hydroxide. So we know that metal hydroxides are bases. We know that metal hydroxides are bases, and that is formed by these oxides. So these oxides are basic. So basic oxides, when dissolve in the water or react with water, will form base. Basic oxides, when react with water, they will form base. Similarly, acidic oxides, when they react with water, will form acid. Okay, that's simple. Basic oxide plus water gives you a base. Acidic oxide plus water will give you acid. Aluminum oxide, you have to know two reactions. Because it's amphoteric, and amphoteric means that it can react with acid as well as base. So you should have a reaction that shows that aluminum oxide reacts with an acid to form salt and water. And another reaction, aluminum oxide reacts with a base to form salt and water. Okay, so two reactions here. Okay, now let us see the reactions. I guess these reactions you will know. Okay, sodium oxide will give you sodium hydroxide, magnesium oxide will give you magnesium hydroxide. Okay, which proves that these two oxides are basic. Okay, so this is, I guess you'll manage. Next one, aluminium oxide ka you should know two reactions. Aluminium oxide plus acid gives you salt plus water. Aluminium oxide plus base also gives you salt. Okay. Mahir, have you learned, do you know the formula of, do you know the name of this compound?
Sodium aluminate.
Sodium aluminate. Is it the same formula of sodium aluminate that you have learnt in ICSE?
No, it was NaAlO2. 0.2H2.
Yeah. Very good. 0.2H2O. Okay, 0.2H2O. Now remember that this formula is same as this formula. Okay, this formula is same as this formula. Only thing is that I have written OH4 so that all this I have collectively written as OH4. So this is the formula for hydrated sodium aluminate. Hydrated sodium aluminate. So you can write either this formula or this formula. Anything, doesn't matter. Okay, but guys, you need to practice. You need to practice. I'm telling you. So IGCSE students especially, they will, and even MYP, you'll forget. Oh, what is the formula of sodium aluminate? You know, is it NaAlO2 or Na2AlO3? You know, so there will be confusion. So better spend some time on this and learn these reactions. Then write down all these reactions without looking in the book. And then again, once you finish writing, and then again go and check. Why am I saying? Because these are easy marks. You know, there is no application question here. You don't need to rack your brain. You just need a reaction. Just produce that reaction, get the mark. So it will be very sad if you don't know the reaction. Saina, keep the video on. Naman Modi. Mahir.
Yeah.
Hope everybody is understanding what I'm saying. That please, you know, it's I'm saying through experience. I'm telling you this through experience that students lose marks in this. Okay, and it's so sad that it was straightforward given in the book, textbook, info book, everywhere, and you could not earn that mark. Why? Because you did not spend that time at home to make sure that you know this reaction. You know, so proper balancing, correct formulas, correct products. You know, so please spend the time on these. I will take a random check on these reactions. Random. So make sure that you're spending time on these reactions. You know, something like this you may still manage, because you know sodium oxide plus water is sodium hydroxide. So it's like a balancing and all, you can do it. But these reactions, maybe I think you can manage, but this is something new to you. So please don't lose marks here. It's very easy marks. No application questions, straightforward questions. Sorry. Okay, now oxides of acidic oxides. Acidic oxides may there are three oxides we saw silicon oxide SiO2, and phosphorus made two oxides P4O6, P4O10, and sulfur made two SO2, SO3. Now first we are talking about these four, and this we'll talk about later because these are water soluble. These are water soluble. So you can see that these, all of them will react with water to form acid. Again here, you know, you will forget the name of the acid, like phosphoric 3 acid, or the formula of the acid H3PO3, phosphoric 5 acid H3PO4, sulfuric 4 acid H2SO3, sulfuric 6 acid H2SO4. Here you can take the name sulfurous and sulfuric. Okay, it's the same name that we otherwise refer them to. But please learn the formulas of these acids, of the oxides. So acidic oxides may say these two are like oxides of phosphorus and oxides of sulfur are water soluble. So I can prove their acidic nature I can prove their acidic nature by reacting with water and show that they form acids. So that's how I prove that they are acidic oxide. Okay, now what about silicon dioxide, SiO2? SiO2 will not dissolve in the water. It will not dissolve in the water, nor will it react with the water. So you can't show a reaction like SiO2 plus H2O. Reaction doesn't happen. Like here I said, na, sulfur dioxide plus H2O, sulfur dioxide plus H2O, plus H2O. You can't do that with silica because silica is insoluble in water. Remember, silica is sand. And you know, sand does not dissolve in the water. So how do I show the acidic nature of that? I make it react with a strong alkali, concentrated alkali. Okay, so something reacts with a base to form salt and water. So that something must be acid. Something must be acid because acid reacts with a base to form salt and water as per the neutralization reaction that we have learned. So this proves that SiO2 is an acidic oxide. This proves that SiO2 is an acidic oxide. Okay, so for SiO2, if they ask question, don't react it with water. React it with NaOH. And for, remember this name on the formula of the salt, sodium silicate, Na2SiO3. You all know calcium silicate.
Yeah.
Have you heard of calcium silicate? Where?
Yeah. I forgot the name of the reaction, but it's the
Lag.
so in the
Slag.
chimney factories.
Flue gas desulfurization.
Flue gas desulfurization. Iron
Iron
Flue gas
extraction.
desulfurization.
extraction.
Slag.
Flue gas desulfurization nahi, iron extraction.
Oh yeah.
If you remember, the two
Yeah.
things fallen down here are molten iron and the slag. Slag is calcium silicate, na? Because the calcium oxide reacts with silica to form calcium silicate. Excuse me. So calcium silicate ka formula, if you know, CaSiO3, na, you used to call it CaSiO3. So same hai. Now Ca ki jagah pe sodium hai. But sodium is a monovalent hai, so I will have to take 2. Na2 aa jayega because Ca is 2 plus, Na is 1 plus. So I'll have to take Na2 here. Ca 1 was enough, but Na I require 2. So Na2 SiO3, calcium silicate is a sodium silicate. Okay. Okay, now finally oxides of nitrogen. Now what should you know about oxides of nitrogen? These three oxides of nitrogen you should know. N2O, NO, NO2. Oxidation state is different. Nitrogen 1 oxide, nitrogen 2 oxide, nitrogen 4 oxide. Out of that, these two are neutral. These two are neutral and only this is acidic. Only NO2 is acidic. And how do you prove the acidic nature of that? This is water soluble. So reacted water, you get nitrous acid and nitric acid. So NO2 reacting with water gives you nitrous acid and nitric acid. So this is how you prove. Though this is not a period 3, but this is in the syllabus, nitrogen is specifically mentioned. Oxides of nitrogen is specifically mentioned apart from period 3. So this nitrogen is there in the syllabus. Okay. In fact, many teachers, skip teaching this. Okay, but it's not much. It's not big thing. So you just need to know the 3 oxides of nitrogen. Which are the 3 oxides, and which ones are neutral, which ones are acidic, and the one which is acidic, you need to prove that it is acidic. So make it react with water to form acids. Any doubts here? Any questions? So this.
What is each NO2?
Sorry.
What is each NO2 called?
Nitrous. And this is nitric. Same like sulfurous and sulfuric, no?
Oh yeah.
H2SO3 sulfurous, H2SO4 sulfuric. Any other question?
No, sir.
Okay. So this chapter is mainly knowledge. There is no application here. Okay, so that's the reason why I spend time on learning things rather than understanding. It's not a concept. It's just the information. but make sure that this information you have learnt and remembered properly, because from this part it's very easy questions, like, and straightforward questions, no twisted question, nothing, straightforward questions. So please don't lose marks in this. Okay, any other problems, any other questions?